Lesson 39, using the distributive property. A rational expression is an expression with a variable in the denominator. So, this is just giving you an example of a rational expression because they have, in each of these terms, they have a variable in the denominator. Example 1 wants us to simplify. So, whenever we normally have something out here touching parentheses, and we have something else going on inside, we're usually adding or subtracting, we know that what we have to do is distribute, and that's exactly what we're going to do here. We're going to distribute a over b to the third to everything on the inside. Now remember, whenever we do this, this means that we're multiplying. So I have a over b to the third, and that's being multiplied by a squared over b, plus a over b to the third, because that's what I'm taking to everything, times 3 b squared over z. So, you also know that whenever you're multiplying fractions, we treat this the same way that we would if it were numbers. We multiply numerator times numerator, denominator times denominator. So, a times a squared, remember when I'm multiplying by the same base, I add the exponents. This a is understood to the first, so I have a to the third over b to the third times b to the first will give me b to the fourth because I'm adding those exponents, plus I have a times 3b squared. Well, my coefficient here is a 1. 1 times 3 is 3. A times b squared is ab squared. Remember, whenever they're not like bases, we just tack them together. Over b to the third times z, again, not like bases, so we just tack them together. B to the third times z. This is my final answer because I do not have a common denominator here. This is where I stop. Final answer. Exact same situation here. This is minus 2x to the third y, just so you know. I know it looks ugly. Something that you need to understand, though, is that whenever I have something that isn't in fraction form, I can always change it to fraction form by putting it over an understood 1. So I'm going to take x squared c squared to everything on the inside. So on top, on this first part, I have x squared, and I don't have any like bases. So I'm just going to tack this whole thing together on top. So I have x squared d m y over. On the bottom, I don't have any like bases either. I have c, x, and a. So I'm just going to tack all this together. C squared x squared a minus, on top, I have 1 times 2, which is just going to give me a 2. I have x squared times x to the third. Remember, when I multiply by the same base, I add the exponent, so I have x to the fifth y over c squared times 1 is just c squared. Now at this point, I am not completely finished because although I do not have any negative exponents, I do end up with this x squared over x squared, which I know will cancel. So I have to cancel those. I know they cancel to a 1, but I don't have to show an understood 1. So I have d my over c squared a minus 2, that's a 2, x to the fifth y over c squared. I don't have a common denominator, so once again, this is my final answer. Same thing's going on here. I'm going to distribute what's on the outside to everything on the inside. So on top, I have x squared times x squared is going to give me x to the fourth. Looks like a 9. x to the fourth over y to the negative third times y to the first. Remember, I add the exponents, so negative 3 plus 1 will give me y to the negative second minus, I have 1 times 3, which is just going to give me a 3, and then I don't have any like bases on top, so I have x squared z to the negative second y over y to the negative third times x, which are not like terms, so I'm just going to write y to the negative third x. Now, I have a couple problems here. I have some negative exponents, and I have a case where I have the same base on top and bottom, and I don't want that. So, to simplify this, first of all, here, the only simplification I can do is this negative exponent needs to be made positive, and to do that, I must move it to its opposite location, which is on top. So I now have x to the fourth, and instead of y to the negative second on bottom, I have y to the positive second on top. Minus, my 3 is going to remain on top, and I have x to the second over x to the first. So I can take that smaller exponent, and I want to move it. So I'm going to subtract 1 from here. So I now have x to the first, which I'll just write as x. I have y to the negative third and y to the first. Because they're opposite sign, I want to absolutely move that negative, which means instead of subtracting 3, I'm going to be adding 3. So I have y to the first plus the third gives me the fourth, over z to the negative second I can make positive by moving it across that fraction bar, which means instead of a negative x to the negative second on top, I'm going to have z to the positive second on bottom. I would like for you to try and do B on your own paper at this time. Please freeze the video so that you can work on that. On B, we need to start by making this a fraction because we're distributing that fraction. So we're going to put this over the understood 1. And I'm going to distribute what I have right here to everything on the inside. On top here, I have no like bases, so I'm just going to write it as 3a to the negative first, bm, that's an m, over, again, no like bases, so I'm going to write them in alphabetical order. I have a to the negative second, b to the second, c to the negative fourth, d, plus, on top here I do have a like base, which is a to the negative first plus a negative third is going to give me a to the negative fourth, and then I have c to the negative fourth, over 1 times b squared is just going to give me b squared. Now that I'm here, I need to combine any like bases or move any negative exponents. So I have a to the negative first and a to the negative second. A to the negative second is the smaller, okay, it would be farther left on the number line, so I'm going to move it up, which means instead of subtracting 2, I'm going to add 2. So on top, my 3 stays, and a to the negative first plus the second gives me a to the first. I have b to the first and b to the second. I'm going to move the smaller one, which is b to the first, and I'm going to move it down here, which means I'm going to subtract 1 because this was positive. I'm going to do the opposite, which is to subtract. So I have b to the second minus the first gives me b to the understood first. My m is to the first, and I don't have an m on the bottom, so it's just going to stay. I have a c to the negative fourth, which I need to make positive, and I will by moving it up. Make my fraction bar a little bigger here. So I will have c, instead of a negative 4, it becomes a positive 4 when I move it across the fraction bar. And my d doesn't change. Okay? Plus, on this one, I don't have any like bases, but I do have 2 negative exponents. So I need to move each of those across the fraction bar to change them to positives. So on top, because both of those moved, I'm left with the understood 1 over a to the 4th, b to the 2nd, c to the 4th. Final answer. Okay, these are doing the exact same thing that we've been doing. The only difference is that there are 3 terms on the inside, so don't be scared by what you see. I'm going to take what I have on the outside and I'm going to distribute it to every term on the inside. This one is not a fraction, but I can make it 1 by putting it over an understood 1. F times f gives me an f squared, because it's f to the 1st times f to the 1st. G squared times g will give me g to the 3rd, because g to the 2nd plus to the 1st gives me the 3rd. X over, I have h times h, which gives me h squared, plus this 4, I'm just going to tack on with the rest of that, so I have 4f g squared over h squared minus 2, and then I have g squared times g gives me g to the 3rd f x, because the f and the x don't have like bases, we just tack them together there, over that h, because 1 times h gives me h. Now at this point I do have like terms, so I could write this over 1 h squared and just put this numerator plus this numerator over h squared, but I'm thinking that your book probably doesn't have you do that just yet, so we're just going to leave it as it is. This is the more challenging one. I would like for you to try and do it on your own paper, so please pause at this time. On this one, we again are going to take what we have here on the outside of these parentheses and we're going to distribute it to every term on the inside. Our middle term here isn't a fraction, but we can make 1 by putting it over 1. I have m times m to the negative 2nd. 1 plus a negative 2 is going to give me m to the negative 1st. N to the negative 4 plus 1 gives me n to the negative 3rd. And then I have r over p to the negative 2nd times p to the 3rd. Negative 2 plus 3 gives me 1, so it's just going to be p to the 1st minus m, there's no like base here, n to the negative 4th times n to the 4th. Negative 4 plus 4 gives me n to the 0, and anything raised to the power of 0 is equal, this should be equal sign, to 1. Okay, so I'm not going to show the n, and then I have r to the negative 2nd over p to the negative 2nd times p to the 1st gives me p to the negative 2nd, plus I have 8 m to the 1st times m to the 1st gives me m to the 2nd, n to the negative 4th, over I have p to the negative 2nd times p to the 1st. Negative 2 plus 1 gives me p to the negative 1. And at this point, all I need to do is make some negative exponents positive. So on this first term, I have m to the negative 1st, which I'll make positive by moving it to the denominator. I have n to the negative 3rd, which I will make positive by moving it to the denominator. So on top, I'm left with just r over m to the 1st, n is now to the positive 3rd, and p, minus, I need to move this r to the negative 2nd down, and this p to the negative 2nd up to change their signs. So I have m, and then the p to the negative 2 came up, so I have p, which is now to the positive 2, over r, which is now to the positive 2, plus I have 8 staying on top. M squared isn't moving, but these negatives have to move, so p to the negative 1st is coming up, which is going to make it p to the 1st, which I don't need to show as 1, but I will because I accidentally made a dot, over n to the negative 4th, which I have to move down, and that becomes n to the positive 4. Final answer. A triangular section of a building has an area represented by this expression. Simplify the expression. I want you to do this on your own paper, and if you are unsuccessful or you don't feel like you have the right answer, I want you to make a note in your notes so that you are sure to ask me about it tomorrow. I hope that you've taken good notes and that you have a good night.